Hello everybody and welcome back. So in this week we're going to be diving into the Python SOP. So basically we're working with the same language but now on a much different context, and the way that this operates is kind of a little bit different as well, but because we have access to the entire language that we learned up to now, it kind of gives us a lot of flexibility. So I'm just going to drop down a geometry node just so I can dive inside to SOP context and drop down a Python node. So it's just called Python. Okay, just Python. There we are. All right. So the first thing you're going to notice is that it basically looks a lot like a wrangle. Okay, so it's basically like the Python equivalent of doing, like Vex code at sort of SOP level, working with geometry. Well, that's what this Python SOP is doing. But it has certain benefits over Vex, but then also obviously certain downsides. So, we're going to use these two interchangeably. Obviously, this course is focused on this, but I mean, as a TD, you're going to basically be using these two depending on what you're doing. In fact, to be honest, most of the time, if you're doing simple things, you can just achieve it with a wrangle. Not that Vex can't do complicated things; it really can, but complicated in a certain way, complicated within the realms of geometry and what it is specifically meant to do. Wrangle does it well, and in fact does it better, a little bit faster. The way that it compiles it, it's very efficient, but it is not a very user-friendly language. Python's easier to pick up, and a lot of people enter into Houdini already knowing Python, or can pick it up learning other bits of software, because it is kind of cross-software, cross-platform, whereas the Vex is very, very specific, and few people do know it, so you have to very much go out of your way to learn it. But once you do, obviously very powerful. So anyone who hasn't done the Vex course might want to look at that as well. So I do end up using these two interchangeably, but a lot of the time, very specifically on geometry, I'll use a wrangle. But there are certain things that Python can do that Vex cannot. And so sometimes we definitely need to use a Python node. So one of the major differences you're going to notice with this Python SOP is that it has no run over context. With the wrangle we've got here, where we actually have to choose what we're running over. So we're running over points or vertices or primitives, or you can then loop a certain number of times, or you can run over detail, which is just once. Okay. Now the Python SOP doesn't really have that option. For all intents and purposes, it's essentially running on detail all the time. It executes its code once, but within that we can loop over primitives, points, and you can even have nested loops and things like that. So you can do a lot. You can also do those same things in Vex, so you can just go on detail and then loop, and that is something that we actually do in the Vex course. But Python does it very, very well. It's very flexible as a language, and in terms of like how you would loop over things, and then maybe even create generators and things instead of actually full-on lists that we have to loop through. It in some ways can actually be more efficient than the wrangle, even though Vex compiles a lot easier. Okay, and then basically, yeah, like I said as well, Python is just a very user-friendly language, and it extends well beyond the context of geometry or whatever we're doing. Vex is very much limited to working within this. Okay, so that when you run this Vex code, it's executing what's here. Okay, and sure, it can look at your 4 inputs. It can even look at other nodes. You're not limited to just the 4. You could have a null somewhere, with an out or whatever, and reference that inside of your Vex code, sure. So you can essentially reference other SOPs to grab information, but really you're operating on one and making some changes to it and outputting it here. But Python extends well beyond that. So Python is going to allow us to, go grab anything from elsewhere in the scene, different parameters, or check other things. You can even have it run the code and then wait for for something and then execute it. It can check the time for you if you want, or it can go through your computer and check if a certain folder exists, and if it doesn't exist, it can create it for you just whenever this your geometry executes. Now, obviously, that means you need to be very careful of what you tell it to do, because every time this cooks, that is when it's going to execute. So let's say we have some geometry, whatever, and then we have a Python SOP running on that. Every time this node loads, when we load our scene, or if the box changes, so as the box changes, that's going to force that to change, which says, okay, my display and render flag is here. This geometry changed, therefore I have to push those changes all the way downstream, so the Python SOP's going to cook again. And when this cooks, if we're telling it to go and create a folder, and we're not very careful about how we do that, then now we're going to have two folders, or we're going to have errors occurring depending on how we're creating the folder. Whereas we basically just need to be very smart about the way we create things if they are possibly destructive. So we would have to maybe first check, does the folder exist? If not, then create it, because then it doesn't matter how many times this cooks. That simple if statement check is going to happen once, and then it goes nope, and then doesn't create the second folder. But even that, we need to be careful how we do the check, because if that check is very complicated, checking that a folder exists, that's really easy, but maybe we want to check several different factors, check the time, check the user, check this, check that, and then decide whether to do something or not. If we're doing that on every time with this Python SOP cooks, that's not ideal. So it's kind of a double-edged sword, these Python SOPs. They can be incredibly powerful, incredibly useful, but for very specific contexts and other ways, something like maybe creating a folder or whatever, something that you want to do once and you want it to only happen when you, the user, choose for it to happen. Something like that is better on maybe a shelf tool or a button on an HDA that has a callback, which are other things that we'll cover. But the Python SOP really is designed to work with geometry. So even though it can do all of these crazy things beyond what geometry can do every time it cooks, we need to be very particular about what we allow it to do. Okay. Otherwise it becomes heavy, and then really we're better off just going with the wrangle. Okay. So that's just sort of how this works. Now, also, I just want to point out that you don't have to have an input. It's actually the same as with the wrangles as well. Like if you have a first input, your first input is what comes out the other end. Okay, so if I have this plugged in here and put that, whatever this is doing, doesn't matter what it's doing, it's really going to basically spit that out the other end, except with any changes that happen inside of here. So maybe inside of here, if I go and delete one of the primitives, well, one of the polygons, then sure, the altered version is what's going to come out. But really the first input is the special input. Okay, so that's what's getting passed through. And then the other three are just references. So if that came into the second input, it's totally fine to accept that, but it's not going to necessarily spit anything out unless I do something inside of here. What I'm feeding it is empty geometry, which it can then go and do stuff to and reference this over here. Now, you can have literally nothing plugged in, and it's still totally fine. You can create geometry. So we could actually create this box, but doing it in Python. Literally go and create all the points, all the polylines and the primitives, and you could literally construct a box in Python code over here. All right. Now let's take a look at what's inside of a Python SOP already. So as we drop one down, it already has code, unlike with a wrangle. But this code is optional, so do not worry. If you want to, you can clear it. Okay, this is just essentially trying to help you get started, and it even kind of tells you here, so add code to modify the contents of the geometry, right? Like I was saying, we can actually go beyond geometry, and then they also have a couple of examples. Well, I mean, they've only got one example. That's not great, but. Maybe they intended to have more, and then they wrote this, and then they just made one and gave up. But it doesn't matter. We're going to be doing plenty of examples. So you don't need that because that was all commented out. And this is just to help fast track things for you. So if you don't need this, it's also a good idea to get rid of it. But most of the time, if we're working with geometry, we are going to need this. Okay. So what this is doing is running just on the Houdini module. It's running a PWD function. Okay. Now what PWD is, if you haven't done any other coding, this might be a little foreign to you. But really what it comes from is, it essentially means print working directory. And what that equates to is essentially saying self, myself. Okay, like it's a quick function to reference where we currently are. So here, right now here in this code, we're inside of this node. So it's essentially like almost like on those maps in the malls where it says you are here. That's what PWD is. Okay. And so it returns the current context. So we're running it in a node, so it's returning essentially a reference to our own Python SOP. Okay. It would be the exact same as saying who.node and then putting just dot. Okay. In other words, reference myself. Okay. So yeah, you will see this come up quite often, but depending on which context it's in, it will change because it's saying reference self, whereas who.node and then with a dot, that's just referencing our current node. Okay, so we will use that later on, especially when we get to the HDAs. It's very useful. So it's essentially creating a reference to ourself, our own node, and then we're using that node reference and running the geometry function, okay, which means that this geometry function is a function of, so it's a method of the who.node class, and what it's returning is a reference to the actual geometry. So now this is something we need to note. We cannot just reference our points like we do with a wrangle. In here, as it comes in, you already absolutely have access to your points, okay, because when you're looping over points, it literally every time it's looping over every single point, and you have a reference to that point. In Python, we have to create that. Okay, so it's essentially kind of this is just empty code, and now we have to tell it, well, go inside of the geometry, give me a reference, a handle to that geometry, so I can go and actually work with it. Okay. Now let's take a look at this geometry module and the function, because we're not going to go deep into it now, because we are actually going to be covering that next, and there's a lot. It's the same as with the who.node class and the who.parm class. There's a lot to it, so I'm going to go over that in a separate lesson. This is just an intro to the SOP, but I just want you to sort of understand what we're talking about. Now, if we go to the who.node class, because obviously we've run this function on a node. Okay, so who.pwd is giving a node, so now we go and look on node for geometry. So if we go over here and look, and let's type filter, so geo, and you'll see that absolutely nothing pops up. And the reason for this, and it's something that I have alluded to before, is that you'll see here in this inheritance section, it's essentially saying that there's a master class, a parent class, which then has a child, which inherits most things from it, although certain things can be deliberately dropped, and then it can have its own additional things added to it. Okay, so the who.network movable item has most things that the network item has, functions and other subclasses and submethods and stuff, but it also might have additional things. And the who.node is a child of that node, so it inherits everything from that, but then also has its own things. For example, network movable item, your sticky notes, those oh, hang on, sorry, don't drop them like that. Yeah, these sticky notes. That's a network movable item as well as a node. Now, obviously, there are some functions that the nodes have that the sticky notes don't have, and vice versa. So on the sticky note, you can, they'll have a function that'll allow you to control what content is written inside of here. And a node does not have that. but they both have certain functions in common, like being able to basically move it. You can shift this up. Well, you can shift this up using code as well. You can change this color. You can also change this color using code. Okay, so they have certain functions in common. And then, in fact, if we middle click on this and go and have a look at this, you'll see what things they have in common. Okay, so they have names, they have paths, you can check their parent, you can select them, you can change their color. So these are all the things, and you can move it. These are all the things they have in common, but then the who.node has a whole bunch of additional things. Now, that is exactly the same with all of these children of who.node. Okay, and because just any node cannot access geometry, for example, this ironically, this geo node on the top here is just an empty container, right? It's essentially got transforms. It's basically a matrix. Okay, and this container has whatever we want inside of it. Now, inside of it, it has geometry, but it itself has no geometry. It's essentially the box. It's like you get a package delivered from Amazon or whatever. The box is containing your item, but the box itself is not a new TV or whatever you got inside the box, right? The box just carries it, and when you move the box, sure, it moves everything inside of it, but it is not its contents. Okay, and that's the same thing. So these have no access to any geometry. They are just a box. This is actual geometry. Okay, I mean, at the moment we have 0 points, 0 primitives, but even empty geometry is still geometry. Okay, and so the reason why so this has geometry, that does not, means that we have to go to a subclass, right, to access that geometry, because the node itself does not automatically have access to geometry. Only certain subclasses have access to geometry. And in fact, I'm not really sure that any do. Maybe dop nodes do as well, and pops, but what we're looking at is primarily the who.sop node. Okay, because this is then any node inside of SOP context has geometry, even if that geometry is empty. Okay, and you'll see that when we go to this this class, there is now also a subclass inside of that, which is who.geometryDelta. Okay, so there's all this sort of inheritance of every class has other subclasses. So now under who.sop node, you'll see that it has geometry, and it has a whole bunch of other functions as well. All right. So now in fact, it even shows you here that it tells you which methods it has inherited from other its parents. So for example, its top level parent is who.network item, and from that it has inherited this function. Okay, and then from the network movable item, it has inherited these functions. So in its own class, it's not defining the name function, because this already has defined a name function, and it's inheriting everything from its parent. Okay, well, not everything. It's inheriting these specific functions from its parent, and it's inheriting these from the node. Okay, so you'll see a lot of functions in here that are in common, but there will be additional, these ones at the top here are additional ones that are defined only inside of the who.sop node class. Okay, so I hope that clarifies that, because I mentioned it before, but this is actually a really good way of showing exactly how it works. So now this geometry function is what we're running in here, but you'll see that there's actually quite a few, because we can grab geometry delta, we can grab geometry at a particular frame or from another particular input. So there's a lot of actual ways we can grab geometry, but in this case we're just grabbing our normal geometry. Okay, and it's going to return a reference to a who.geometry class, which is a whole class on its own, and that's what we're going to be going through in the next lesson. And it's actually good to read in here. This specifically mentions that this is returning geometry which is not frozen. Okay, when we loop through geometry, what we can do is we can even be destructive. We can delete points. We can destroy points inside as we're looping through it. Okay, and when we do that, it can break the loop. It's essentially like trying to build a bridge, but then as you're walking over the bridge, if you start breaking the bridge behind you, like burn the bridge behind you, you might not make it across, because once you burn the bridge behind you, the whole thing collapses. And so, you basically need to you need to create this reference to frozen geometry. So it's kind of like creating a sort of copy of it. And you loop over the frozen geometry, but remove points from the original geometry. So then as you've deleted those points, your frozen version still has all, let's say you've got 100 points. It still has a reference to all 100 points in this kind of pseudo like copy. And you loop through those 100 points in your frozen geometry and remove whichever ones you want, but you don't remove them from the frozen one, you remove it from the original. Okay, so it's kind of like burning a fake bridge. Well, no, it's like burning the original bridge, but you're standing on a fake one, and kind of highlighting which parts you want to be destroyed or burned or rebuilt or whatever, and then someone else on the other bridge is actually doing it for you, and so you don't, you're nice and safe on this copy. Okay, so that's sort of what's happening here. So this is what we're doing here, is referencing a who.geometry class. Okay, so this function returns the geometry, and very much just note that this is lowercase g. Okay, so this is the function, the method, okay, on a SOP node class, which is what we have here, that returns a reference to the instance of who.geometry. So with capital G, that is the class. Okay, it's the exact same as with the nodes and the parameters. Right, and now this class is what we're going to be going over in the next lesson. Okay, so we'll be talking about this all soon, and how to work with it. Okay, so that about wraps it up for the intro to these SOPs. Okay, just primarily they are very powerful, very flexible, and can do a lot of things that Wrangles cannot do. But I also tend to use them rarely, because those situations where you do use them are only very specific. And we'll be doing some examples in this course where you need to use actual Python SOPs. But for basic things, still stick to your Vex if you know Vex. Okay, if you don't know Vex, go and have a look at the Rebel Way Vex course. But also for now, if you don't know Vex and you do know you're learning Python now, well then great, then you can use your Python SOP. But just know it will be a little slower than Vex, but it is infinitely more powerful and flexible. Okay, but just be very careful what you ask it to do in SOP context, because this is going to cook every single time. Like if we middle click and anything has changed upstream, it's gonna cook. Or if we disable it and re-enable it, it's going to cook. Or anything changes, like when we hit render, it's going to cook. We move frames, it's going to cook if it's time dependent. So you need to be really careful what we tell it to do. Okay, so thank you everybody, and I look forward to the next lesson where we will be going over the who.geometry class and everything that it has to offer. Okay, see you there.